Every Soviet aviation documentary celebrates the Shvetsov ASh-82 as indigenous Russian engineering that powered legendary fighters like the La-5 and La-7 to victory. But declassified industrial records reveal a different story. The ASh-82 began as an American Wright cyclone design that Soviet engineers licensed and mass-produced under catastrophic conditions. The engine succeeded despite deadly reliability problems, disastrous production quality, and performance specifications inflated for propaganda purposes. This isn't the heroic narrative Soviet textbooks taught for decades. The Shvetsov ASh-82 story begins not in Soviet design bureaus, but in American factories. In 1933, the USSR purchased manufacturing rights to the Wright R-1820 Cyclone, a proven 9-cylinder radial engine powering American military and commercial aircraft. The licensing agreement included complete technical drawings, manufacturing specifications, and metallurgical formulas. Soviet engineers were supposed to produce exact copies while paying royalties to Wright Aeronautical. That's not what happened. Within 2 years, Soviet factories were producing modified versions without royalty payments while claiming the changes constituted indigenous development rather than licensed production requiring compensation to American designers. The initial Soviet designation M25 made no secret of foreign origins. It was essentially a Wright Cyclone built in Soviet factories. But as political tensions grew and Stalin demanded technological independence narratives, subsequent developments received purely Russian designations that obscured American foundations. Within 2 years, Soviet factories were producing modified versions without royalty payments while claiming the changes constituted indigenous development rather than licensed production requiring compensation to American designers. The ASh-82 evolved from the M25 through incremental modifications. Displacement increased from 29.9 to 41.2 liters, compression ratios rose, and supercharger systems were redesigned. Soviet propaganda emphasized these changes as revolutionary Soviet innovations while systematically omitting that every fundamental design element – cylinder head configuration, valve train architecture, crankcase structure, and cooling fin geometry came directly from Wright's original specifications that American engineers spent years perfecting. Post-war Soviet aviation histories described the ASh-82 as Arkady Shvetsov's masterpiece of indigenous design. Western reference works repeated these claims for decades because researchers couldn't access classified Soviet archives documenting the Wright Cyclone heritage underlying every component. But the origins controversy was nothing compared to what happened when wartime production began. When Germany invaded in June 1941, Soviet aviation industry faced catastrophic disruption that turned ASh-82 production into organized chaos. Factories in Western USSR, where most engine manufacturing capacity existed, lay directly in the Wehrmacht's path. Stalin ordered complete industrial evacuation eastward beyond German reach. Between July and December 1941, Soviet workers dismantled 1,523 industrial facilities and transported them by rail to the Urals, Siberia, and Central Asia, while German armies advanced within artillery range of factory gates. The ASh-82 production facilities in Perm were packed into railcars and shipped 800 miles east, reassembled in hastily constructed buildings, and ordered to resume production immediately. The result was predictable disaster. Precision machine tools arrived damaged from transport. Critical components were lost during evacuation. Experienced workers were conscripted into frontline units, replaced by women, teenagers, and elderly men who'd never seen an aircraft engine before. Factory managers received production quotas that assumed peacetime conditions while working in unheated buildings where winter temperatures dropped to -40 degrees Fahrenheit and machinery froze solid overnight, requiring blowtorches just to restart production each morning. Quality control became impossible under these conditions. Dimensional tolerances that Wright cyclone specifications demanded, measured in 10,000ths of an inch, couldn't be maintained by inexperienced workers using damaged equipment in freezing conditions. The workforce composition reflected Soviet desperation, with 14-year-old apprentices operating precision lathes beside 70-year-old pensioners recalled from retirement, neither group possessing adequate training or physical capability for manufacturing components requiring expertise that normally took years to develop through supervised apprenticeship programs. Inspectors faced impossible choices: reject engines for specification violations and fail production quotas, or approve defective engines knowing they'd fail in combat. Production quotas always won. Engines that should never have left factories were crated, shipped to frontline units, and installed in fighters defending Stalingrad and Moscow. Stalin's regime treated production failures as sabotage requiring execution, so managers approved engines with known defects rather than face NKVD firing squads, creating a system where survival meant sending defective equipment to pilots whose lives depended on reliability. The evacuation chaos established manufacturing patterns that plagued ASh-82 production throughout the war, but the real problems emerged when those engines reached combat units. ASh-82 operational reliability proved catastrophically worse than specifications promised, creating maintenance nightmares for Soviet fighter regiments that depended on engines frequently failing mid-mission. Mean time between major failures averaged significantly lower than German or Allied equivalents, forcing constant engine changes that crippled operational readiness. The most common failure mode involved main bearing deterioration. Crankshaft bearings manufactured from inferior Soviet alloys couldn't withstand operational stresses that Wright cyclone metallurgy handled routinely, causing bearing surfaces to degrade rapidly under combat power settings until catastrophic seizure occurred without warning during flight. Pilots reported total power loss followed immediately by seized propellers and engine fires, giving insufficient time for emergency procedures. Documentation from the 159th Fighter Aviation Regiment showed that between March and August 1943, the unit lost 17 Lay-5 fighters to catastrophic engine failures during combat operations, compared to only 12 aircraft lost to German fighters, creating the grim statistical reality that Soviet pilots faced greater danger from their own power plants than enemy action. Oil system problems compounded bearing failures. The ASh-82's lubrication system couldn't maintain adequate oil pressure during sustained combat maneuvering. High G turns caused oil starvation to cylinder heads and bearings, accelerating wear catastrophically. Pilots learned to avoid prolonged turning fights not because of tactical disadvantages, but because their engines would destroy themselves during extended high G maneuvering that drained oil from critical bearing surfaces. Cooling system inadequacies created chronic overheating during summer operations. The air-cooled radial design depended on adequate airflow across cooling fins, but combat situations frequently required reduced airspeeds where cooling became marginal. Pilots operating at low altitude in summer heat faced constant temperature warnings, forcing power reductions during critical engagements. Maintenance requirements exceeded anything Soviet logistics could support. ASh-82-powered regiments maintained operational readiness rates 30 to 40% lower than units flying earlier engine types. Each engine required complete overhaul after just 100 combat hours compared to German BMW 801 radials achieving 150 hours and American Wright cyclones reaching 200 hours before major maintenance, meaning Soviet units spent more time changing engines than flying combat missions. Multiple fighter regiments documented losing more aircraft to mechanical failures than to German action during 1942 to 1943, but these statistics were immediately classified to prevent negative impact on military morale and public confidence in Soviet equipment. Soviet propaganda published ASh-82 specifications that bore little relationship to actual operational performance, creating dangerous gaps between pilot expectations and aircraft capabilities that proved deadly during combat. Horsepower ratings represented the most significant specification inflation. Official Soviet publications claimed ASh-82 FN variants produced 1,850 horsepower at war emergency power settings, but German technical intelligence testing of captured engines documented actual output of 1,330 horsepower under identical conditions, a 28% specification inflation that misled Soviet pilots about their aircraft's actual capabilities. The horsepower gap directly affected combat performance. Leh-5 FN fighters were briefed as capable of matching FW-190 performance based on propaganda specifications, but actual power output left them significantly disadvantaged in vertical maneuvers and high-speed engagements where published specifications suggested parity. Soviet pilot training manuals contained performance charts based on propaganda specifications rather than operational reality, teaching combat tactics that assumed power-to-weight ratios the aircraft never actually possessed, resulting in fatal misjudgments when pilots attempted maneuvers their engines couldn't sustain during actual combat encounters with German fighters. Altitude performance specifications contained systematic falsification. Soviet claims indicated full power maintenance to 20,000 feet, but operational testing showed severe power degradation beginning at 16,500 feet, with combat effectiveness disappearing above 18,000 feet. Pilots briefed to intercept high-altitude German reconnaissance aircraft discovered their engines couldn't maintain combat power at altitudes where mission planning assumed full capability, forcing them to abandon intercepts or risk stalling during climb attempts. Fuel consumption specifications deliberately understated operational requirements by approximately 35%. Published consumption rates proved fictional compared to measured operational appetite that reduced combat radius and endurance catastrophically below mission planning assumptions. Fighter pilots discovered actual combat radius was 40% shorter than briefings indicated. Weight specifications systematically underreported installed engine mass by excluding mandatory accessories, exhaust systems, and installation hardware. The concealed weight increases, approximately 285 pounds beyond published specifications, degraded aircraft performance while misleading designers about penalties associated with ASh-82 installation compared to inline engine alternatives they were replacing. Yet despite all these problems, the ASh-82 succeeded in ways that surprised everyone, including the Germans who faced it. The ASh-82's ultimate success had less to do with engineering excellence and more to do with strategic timing, tactical advantages, and desperate necessity that made flawed radial engines preferable to failed alternatives. Air-cooled radials proved more survivable than liquid-cooled inline engines in combat damage scenarios. A single rifle-caliber bullet through a coolant line would destroy an inline engine within minutes as boiling coolant sprayed from the damage, but the same hit on an ASh-82 might destroy one cylinder, while the remaining 8 continued producing 85% power, allowing pilots to return home rather than bail out over enemy territory. This survivability advantage saved hundreds of Soviet pilots. German pilots reported frustration at pouring rounds into La-5 fighters that absorbed damage and kept fighting, compared to Yak fighters with inline engines that died from single coolant system hits. Combat reports from Jagdgeschwader 52 documented multiple engagements where German pilots observed their cannon strikes hitting La-5 fighters squarely, producing visible explosions and smoke trails that should have indicated kills, only to watch the same aircraft continue fighting and eventually escape rather than falling as anticipated, based on previous experience with inline-engined Soviet fighters. Production simplicity allowed mass manufacturing under impossible conditions. While inline engines required precision machining and tight tolerances throughout, radial engines tolerated cruder manufacturing. Soviet factories could produce 3 ASh-82 engines in the time required for 2 inline engines while using less skilled labor and cruder machine tools, meaning the radial's production advantages outweighed its reliability disadvantages when Stalin needed thousands of engines monthly. The engine arrived when Soviet aviation desperately needed alternatives to failing inline designs. Multiple Soviet inline engines suffered catastrophic reliability problems during 1941 to 1942 that made the ASh-82's flaws seem acceptable by comparison. Fighters needed engines immediately, and the ASh-82 was available when nothing else worked. Tactical doctrine evolution favored the ASh-82's characteristics. Soviet fighter tactics emphasized low-altitude interception and ground attack, where the radial's disadvantages at high altitude didn't matter. German bombers operated primarily below 15,000 feet over the Eastern Front, exactly where ASh-82 performance remained adequate, despite high-altitude limitations that would have mattered in Western European air war conditions. The engine's distinctive sound became a psychological weapon. German ground troops learned to recognize the ASh-82's roar, creating fear disproportionate to actual capabilities. The radial succeeded not through superiority, but through availability and adequacy when Soviet aviation needed both desperately. The ASh-82's legacy reveals uncomfortable truths about wartime aviation development. Perfect engineering matters less than adequate availability, and propaganda specifications serve political purposes regardless of operational reality. The engine that Soviet textbooks celebrated as indigenous triumph was actually licensed American design that succeeded despite catastrophic production quality, deadly reliability problems, and systematically inflated performance specifications that endangered the pilots depending on accurate information. Yet, it powered Soviet fighters through the war's most critical period when alternatives had failed completely. The La-5 and La-7 fighters equipped with ASh-82 engines achieved kill ratios that surprised German intelligence analysts who tested, captured engines and knew their actual limitations. Soviet pilots learned to fight within their aircraft's real capabilities rather than propaganda specifications, developing tactics that exploited survivability advantages while avoiding situations exposing performance gaps. Veteran Soviet fighter pilots developed unofficial knowledge networks sharing actual performance data that contradicted official specifications, teaching new pilots the real limitations and capabilities through word-of-mouth transmission that circumvented propaganda while ensuring combat effectiveness despite being trained on fictional performance charts that bore no resemblance to operational reality. Modern Russian aviation histories continue describing the ASh-82 as indigenous Soviet innovation while minimizing American Wright cyclone heritage that licensing agreements and technical documents prove conclusively, perpetuating nationalist mythology that serves current political narratives rather than historical accuracy. The wartime production disasters, reliability crises, and specification frauds remain largely unexplored in Russian publications because acknowledging these problems contradicts carefully constructed narratives about Soviet technological achievement during the Great Patriotic War. Western historians gained access to Soviet archives after 1991, revealing documentation that contradicted decades of propaganda about indigenous development and superior performance. Yet the mythology persists because dramatic narratives about Soviet engineering genius prove more appealing than complex realities involving licensed American designs manufactured under catastrophic conditions that somehow succeeded through desperate necessity rather than technical excellence. The ASh-82 proved that wars aren't won by perfect engines but by adequate ones available when needed most. The Shvetsov ASh-82 wasn't the indigenous engineering masterpiece Soviet propaganda claimed. It was a licensed American design mass-produced under disastrous conditions, plagued by reliability problems that killed pilots, and marketed with inflated specifications that had little connection to operational reality. Yet it succeeded when Soviet aviation needed it most. Function beat perfection when survival demanded immediate solutions. Watch the next video for more aviation truths on vintage planes.